Hi everyone. So today we are looking into our last functional group, and it is this very special group called aromatic hydrocarbon. Now, uh, aromatic, okay? What does that mean? Now, you might have not heard of this word. I might have not told you, or I might have. I don't remember. But aromatic is cyclic. Not just that, with resonance. Oh, okay. Resonance. Does anybody remember what that was? That's right, electron delocalization. Meaning that the electrons have the ability to move around and be bonded to different atoms inside the same molecule. Now, the example that we're going to do for hydrocarbon, of course, is C6H6. Now, I remember asking you to build one of these things back in October, and a lot of you gave me, of course, this. That. Of course, here are the hydrogen. And we gave it a name. This guy is called benzene. Okay? Extremely stable molecule. Now, how am I going to illustrate electron delocalization here? It's very simple. You see these double bonds? You see this double bond right here? Let's just say it starts with this double bond. This double bond have the ability, of course, to move its positioning. Let's say this carbon says, I don't want a double bond with you. I want a double bond with that guy. No problem. No problem. This will move over here. Now, when that happens, this guy is going to say, hey, I already have 5 bonds, but I really want a double bond with you. So what am I going to do? I'm going to move this over here. Okay? This guy will say the same thing, and it will move its double bond over here. As a result, you get this. You get that. Now, I would say they're the same molecule. The difference, of course, is where the double bond is being placed, because electrons are delocalized. Okay? Meaning that in 1 second, benzene might look like this, but in the next second, benzene will look like this. Okay? And in the next second, these electrons say, hey, I want to do this. As a result, it will look like this again. Okay? So these two structures are not really isomers, but they're resonance structure. And hopefully you remember, this is what we use. These double-headed arrow is what we use to illustrate resonance structure. Now, don't be mistaken this arrow with the equilibrium arrow. Okay? So make sure you kind of make that distinction, because it's actually quite important that you don't mix those two arrows up. So benzene is what we call aromatic hydrocarbon. Okay, it's one of the many examples of aromatic hydrocarbon, but of course it is the example that we're going to focus on for a while. Okay, for the next couple of days actually. So this functional group deserves 2 days of work. You know it's important when we have to do something like that. All right, let's take a look at how some example of benzene. Okay, and how we name benzene having side group and stuff like that. So let's start with part A. Mono substituted benzene. Okay, now mono means one. That's obvious. Substituted, of course, is a substitution. What are we substituting? We're substituting the hydrogen. Okay. If you look back up here, each carbon is bonded to one hydrogen. When we're substituting, we're actually substituting these guys. Okay, obviously we can't substitute these guys. That would be ridiculous. But we're substituting these hydrogen with something else. And when we do that, how are we going to name those guys, huh? So, hey, let's get right on it. Now, so to draw benzene, okay, we're not going to draw those double bond because we don't know if the double bond is like this or like that. Okay, because as I said, in 1 second it may be like this. In the next second it'd be like that. So what do? We put a circle in the middle, showing you electron is being delocalized. Okay? So whenever you see a benzene ring, it should have, of course, not only the hexagonic structure, but a circle in the middle as well. All right, let's look at some monosubstituted benzene, and let's substitute it with various things. Let's start with halogens. Okay, what would he call these guys? Well, very simple. You would just say chlorobenzene. Okay. What if my substitution was something else, like a bromine at this position? No problem. Bromobenzene. And of course you would have iodobenzene, fluorobenzene. I mean, no big deal, right? Here. We've seen this guy before. He would just be called nitrobenzene. So, pretty simple. Very, very simple. Now, here are a couple of them. Oh, let me just give you one more. Let's put some hydrocarbon groups. There you go. You would just say ethyl benzene. All right, ethyl benzene. Now, tomorrow we'll actually talk about priority charts of where benzene is located in the priority chart. You'll be very surprised, okay, how low it's going to be. But today we're not looking at benzene being a side group. We're looking at benzene being the main group. So that's how much work we're going to see today. Okay, it's actually very similar to cyclohexane and cycloalkane that we saw, a couple of weeks back. Yeah, it's been a couple of weeks already. All right, I'm going to introduce you to some special benzene. Okay, special benzene, because this is going to be very important. Now, when you have a benzene hooking up with a methyl group, I wouldn't call it methylbenzene, but it is methylbenzene. Some people might call it methylbenzene, but people call this toluene. Okay, it's actually a common name, but IUPAC also recognizes that as the name for methylbenzene, so they call it toluene. And there's this one. This is called a benzene alcohol. Okay, but we don't call it hydroxybenzene, benzenol, some sort of made-up name. He's called phenol. Okay? Now later on, we're going to see a word called phenol. Don't be mistaken, phenol and phenol. Okay, so phenol is just a benzene with an alcohol derivative. And then there's this one. This one is a carboxyl. An organic acid, remember? We call this guy benzoic acid. Okay, now let's just say these three let me just circle them right now, is important. Not just on its own, but later on when you see disubstituted benzene and polysubstituted benzene, these guys actually come and play a big role in terms of their name. Okay, we're going to see that maybe in 10 minutes. All right, so that's monosubstituted benzene. Pretty simple. Let's move on to disubstituted benzene. Now, obviously the word di means two, so there's two hydrogen here been substituted. So let's take a look at a couple of these. Okay, I have right here, let's use bromine. I'm going to have this. Okay, now if I were to give you this as a cycloalkane, you would say 1,2-dibromocyclohexane, right? So it only makes sense that this is 1,2-dibromobenzene, right? Well, I would like that too. But for some reason, IUPAC decided to play this trick on all of us. They said for common disubstituted benzene. Now the word common means both substitution is the same element or same side group. You should give it something known as the ortho, meta, and para name. Now, what do you mean by that? Now, take a look at this example I have over here. Okay, it doesn't matter if you use this is X or this is X. It doesn't matter. It doesn't matter at all. Okay, as long as you recognize the fact that if this is X, this or this is known as the ortho position. This or this is called the meta position. This one right here is the para position. Okay? So if you chose to have this as X, then these two will be the ortho position. These two will be the meta position, and this will be the para position. But you'll notice that after when you name it, it doesn't change the fact what it will be. So how are we going to name this? Because obviously IUPAC don't want to see 1,2-dibromobenzene. Okay, then what do IUPAC want to hear? Well, let me just tell you the answer. They like to say, oh, dibromobenzene. O stands for ortho. Okay, meaning that the two bromine is in ortho position with each other, which means 1 and 2. All right. I know it's like what the. Here's another one. Okay. 1,3-dibromobenzene, right? No. IUPAC want to hear M-dibromobenzene. Why? Because if you're going to illustrate this as X, this is in the M position, which is really just a 1,3 position. They want to hear M-dibromobenzene. Of course, if you have this, they want to hear P dibromobenzene. Okay, so when do you use ortho, meta, para? Well, you use it when it is first a disubstituted benzene, and these are the same element. All right. So it's strange. It's strange why IUPAC decided to kind of throw a curveball at the naming system. Not sure what's so special about disubstituted benzene that it's the same in terms of element types, but they like to do things like this just to make things a little bit harder for all of us. Anyway, really shouldn't be complaining. Okay, we really should be embracing. Right. All right, let's take a look at some other disubstituted benzene. Okay, here you go. What if they're not the same? Okay, well, if they're not the same, you name them like a cyclohexane. Okay, you would give the carbon number 1 if they have a side group. Okay, now the question is this: just like what we saw with cyclohexane, who is number 1? This guy can be potential number 1. This guy can be potential number 1. Who would be? Well, since none of these guys are important at all, they're halogens, obviously you would want to give it to this guy. Okay. Now the second question is this: clockwise or counterclockwise? Well, if you go clockwise, you see 2, 3, 4, 5. So it's going to be a 1, 5. Counterclockwise, 1, 2, 3. 3, huh? 3 must be better. So this guy is called 1 bromo, 3 chloro, benzene. Okay. So when they're not the same, you can just name them like a cyclohexane. All right. Just when you think things are great, somebody decided to give you this to name. Now, there's no such thing as benzonol, I hope you know. No such thing as benzonol. Benzonol doesn't exist. People are just going to laugh at you if you say something like that. Okay? Now, first of all, when you see something like this, you get to recognize that this is alcohol. Alcohol is important. More important than bromine, that's for sure. So it only makes sense that this carbon is number 1. No doubt. This carbon is going to be number 3. Because you want to make sure that bromine gets the lower number. That's all. But what are you going to do here? Are you going to say 3 bromo, 1 hydroxybenzene? Huh? 3 bromo benzonol, like I said earlier, that doesn't exist? Well, do you remember back a couple of 10 minutes ago, we said this guy is special. Ignoring the BR there. This guy is special. And what was his name again? Now, if you don't remember, I said his name was phenol. Right? And because phenol is important, because it's one of those special benzene names, you name this phenol. You would say 3 bromo phenol. Okay? I know, it's pretty tricky. Pretty tricky. Sometimes. But that's exactly how we have to name these things. Okay? Just like this one. Like that. What are we going to name that? Well, this is going to be 2-fluoro benzoic acid. Okay, because you need to recognize that this is benzoic acid. and this is a floral. Benzoic acid has to be the name because it's basically that important. Okay? Now, let's look at some complicated stuff. It's not really that complicated, but what if you have this situation right here? Phenol, right? But benzoic acid at the same time. What would you call this? Now, this is where, your knowledge of a priority comes into play. Who's more important? Alcohol or carboxyl? No, of course it's carboxyl. So it only makes sense that carboxyl is number one. Not only is it number one, it's also going to be your ending. This guy is a benzoic acid and not a phenol. So would you say 2-phenol benzoic acid? No, you wouldn't say that neither. Okay? You would treat this guy as another side group. So what do you call an alcohol side group? That's right. You're back to a hydroxyl, boy. So this is a 2-hydroxyl benzoic acid. Okay? Hopefully you guys are catching on. Now what about this? Okay. Double phenol, diphenol, 1,3-diphenol, para-diphenol. No. When they say phenol, phenol means benzene with an OH. You have an extra OH? Funny thing is this extra OH is a side group. So this is a 3-hydroxyl phenol. And readers will know that if you're asked, hey, how do you draw this? Well, phenol. I can draw phenol right now. This is my phenol. 3-hydroxyl? No problem. 2, 3. There you go. Okay. So one of the things, of course, with naming things is that if you are able to draw the same thing that you name, and it looks the same as the one that I gave you, you're good to go. Now, funny that I'm bringing this up, huh? Yeah, after benzene, I'm planning to have a quiz on just organic nomenclature, which is everything from alkane all the way to benzene. I'm thinking next Monday. Mm-hmm. Hope that's okay. All right. Any questions about disubstituted benzene? If there's any questions, of course, you know my office hour. You know how to email me. You guys been emailing me about mistakes that I've been making. I'm so glad you guys are picking those up. Last week was a horrible week. All right. Here we go. Okay. Polysubstituted benzene. So here's benzene. I have BR here, F here, I don't know, Cl here, and ethyl here. Okay, what do I do here? Well, this is easy. Nothing special about this. This is going to be just like cycloalkane. Well, you assign a number 1. No, who's number 1? Now, the thing is this, though. Okay? You need to think about who's the most important group right here. Is it hydrocarbon, which are known to be alkyl? Or is it these halogens? Now, this guy is more important. Okay? So this guy will be number 1. Now, who's number 2? Because these two can both be potentially number 2, but one of them has to be number 2. Well, you look at number 3. If this is number 3 and this is potential number 3, which one is a better number 3? Bromo is the better number 3 because of its alphabetical name. So, let's write this down. This is going to be 1 ethyl Okay. 3 bromo. Oh, wait, hold on. I think 3 bromo comes first. Oh, I almost got myself there. 1 ethyl. 5 chloro. 6 fluoro benzene. Okay. Now, what about this? Similar. But instead, this is not an ethyl group. But let's say it's an iodine group. What do? Well, then you have to assign a different number 1. Then you want to make sure that the combination of number is the lowest, because all these guys are the same thing. They're all halogens, so there's no importance. Unlike this guy, who's legitimately a hydrocarbon, okay, an alkyl group overrides halogens. So alkyl group gets number 1 priority. Okay, so what would you call these guys? Well, what would you call this guy? Well, I would say number 1 will be here due to alphabetical order versus here. Because I can easily do 1, 2, 3, 4, 5. But I will give this to be number 1 because it's bromine. So this will be 1, 2, 3, 4, 5. So in this case, I will see 1 bromo. Okay. 3 chloro. 2 fluoro. 5 iodo benzene. Okay. All right. I'm sure you guys get the drift of things. Let me just give you a couple of more to do, and then we're good. All right. Let's take a look at this one. What would you call this? Well, don't be fooled here, okay? Be very, very careful. No hydroxys. Who is this again? That's right. He's a phenol. So, number 1, 2, 3, 4. Okay? So you will say 2 ethyl, 4 isopropyl, phenol. Right? So be very careful. All right. One more. Okay. So you guys can name this. Pause. Unpause when you're ready. All right. Sure you guys are ready? Who's number 1? Well, I will say this guy. Why? Not because this is carboxyl, okay? Not because it's carboxyl. Because this is a benzoic acid. There's a difference in terms of what I just said. Okay? Phenol, toluene, they get override, of course, by benzoic acid. So which makes these guys all psi group. So, hey, how are we going to name this? If this guy's number 1, it only makes sense this is number 2 because there's nothing here. Okay? So, let's go. Number 3, we have a amino. Okay? 2 hydroxyl, 5 methyl, 4 nitro, and of course, would you end your name with what? That's right. Benzoic acid. Okay. So that's benzene. So that's our monosubstituted benzene, disubstituted benzene, and polysubstituted benzene. So tomorrow we're going to look at benzene, but this time benzene is not the most important group. It's actually a side group, and how are we going to treat benzene as a side group? So we'll look at that tomorrow, and what we'll also look at is, of course, a little bit of more amine, because I didn't think I did enough amine with you the other day. We're going to look at more special amines. So we'll look forward to that tomorrow. All right. Have a good day now, guys. Bye.